This is part 2 that continued from Siemens distributed safety module programming. So last time we do for the hardware configuration on part 1. In this part 2 we will do the programming. So let's start the programming. First, let's insert our call function. Okay. Select call F call, and let's insert some function block that all our safety program will be called under this one. This is the main. Okay. Okay, F block is okay, and let's insert one OB organization block that executes our whole safety program. Let's say OB34. Okay, we can adjust the OB execution time on the hardware configuration. Go to hardware configuration. So here, double click and go to the cyclic interrupts. From this, as you see, OB34 time stated, execution time stated 50 milliseconds. That's okay. Okay, now let's insert 1 dB that stores our safety data. It's db1. Okay, this is going to be the also this is safety, so FDB, health safe db, and let's parameterize the db. Password 1212. Okay, this one, side 1, emergency. Okay, this is going to be bull. Okay, side 1, doors are closed. Okay, machine side 1 safe. Good. So this is for side 1. So we have to parameterize for all sides. Okay. So we parameterize db1 like this for all sides. So let's close this one, and now let's start the main functions. I will create one function for each side, so one function will monitor one side only. So for each side we have to configure. Okay, this one is F ladder. Okay, Okay, this one says side one emergency. Okay, so I have two emergencies for side one, and then I will connect them by end. So side one emergency 1, input 0.1, emergency 2, this one memory bit 10, side 1 emergency. Okay, the db will be db1 dot dbx 0.0. so this will tell side 1 emergency. Okay, let's do for the door. Side 1 doors are closed. So I have 3 door switches and 1 interlock. So side 1 doors, input 6.1, input 2, sorry, okay, this will be 11 0. Side 1 doors are closed. The db will be db1 dot dbx 0.1. Okay, now I do for the side 1 emergency and the side 1 doors. So let's add one network that monitors side 1 safety. So machine side 1 safe. So to save machine side 1, the emergencies must be okay or released and the doors must be all closed. Okay, this one is db. For the doors, this one. For the emergency, this one. So if both are safe, then we can say machine side 1 is safe. So we will send this to our machine side 1 safe. Okay, then the memory will be 0.2 machine side. This red highlight is for the address is not safety address, so it highlights by red db1 dot dbx 0.2. This is for machine side 1 safe. So we create one function in the parameterized for side 1. So we will do for all sides. So I have already created that one. So I have created function one for side 1. For the other sides I have already created. So let's close this and save in the close. And let's check the other functions. Function 2 for machine side 2. Okay, so network 1 for emergency is okay. Network 2 for doors are closed. And the network 3 is machine side 2 completely safe. Machine side 3 FPR2 safe, and function 3 for machine side 3, and let's also see that the program is the same, only the parameter is different. So network 1 is for emergency monitoring, network 2 for the doors and the interlock, and network 3 for the whole machine side 3 is safe. If the emergencies on side 3 are safe and the doors are all closed, so we can say the machine side 3 is safe. So likewise, let's see for the network FC4, that's for side 4 emergency. Okay, and network for doors are closed, and network 3 machine side 4 safe. Okay, safe. Okay, for the sides I have created them. Let's add one function that monitors the hardware input modules. Okay, in input module monitoring. If the input modules, one of the input modules are not working, so automatically the safety module will detect that one, because each module have their own DB. So let's DB example input module 10K, so we can get the Q pad signal from that and store to our memory 10.5. okay, for input module 11K, great. 12K, DB 13, so we can put also here for DB 14. This one DB 50. DB 60. db70. Okay, for each module I get their status, so let's add one that monitors overall. Okay. Okay. Okay, I miss one module. That's db12. Okay. db1.dbx1.5. So input module. Okay, we will. So I created for input monitoring. So I have. Okay, this is for the hardware input module monitoring, and I also already created one function that monitors the output modules. Let's see that one. Okay, this one is the function that monitors the status of the output modules. Has 4 modules, one function for all modules. Okay, let's add one function that monitors overall safety of the machine. Okay. Machine completely safe. Machine completely safe. So when side 1 is safe, side 2 is safe, and side 3 is safe, and the side 4 is safe, and also the input output modules are safe, so we can say the machine is completely safe. Okay, db1 dbx 0. Sorry, db1 dot dbx point. Yeah, machine side 1 is safe. db1 dot dbx.5 side 2. db1 dot dbx1 machine side 3 is safe. db1 dot dbx 1.3 machine side 4 is safe. db1 dot dbx 1.5 Input modules are okay. db1.dbx 1.6. Output modules are okay. So our final output will be saved on db1 dbx 2.0. Machine is completely safe. Good. Now let's save and then close this. Okay, now we have finalized our program. Let's open FB100 and call those functions under FB100. Okay. Okay. We call all our functions on our FB100. That's great. Save and close. Now let's open our OB34. Okay. Let's call our main call function FB FC100. Save and close. Great. Now we finalized our programming. Let's compile. To compile the safety program, there is a button on the top, as you see. So click this one. Okay, great. Let's create runtime group. So our call function is FC100, right? Our main functions are called on FB100, so we select that one. Let's create an instant DB100. Yes. Okay, great. Now let's compile. Okay, our program is compiled successfully without errors. That's great. Let's try to download our program on the simulator. Failsafe blocks cannot be loaded to the F CPU. You see, we can't download directly this program to the PLC. So let's continue. Yes. So non-safety blocks are downloaded. But to download the safety, again we have to open this button on the top and download. Password 1212. Okay, done. Let's start again. Okay, now our program is loaded successfully on the CPU. Thank you. I have finalized this part. See you until another video.